Have you ever stared at a super complex blueprint or one of those gorgeous 3D CAD models and just wondered, how on earth do these theoretical drawings actually become real-world components? I mean, it's one thing to design an absolute masterpiece on a screen, right? But it is a totally different beast to literally bring it to life in the physical world. Well, the answer to that mystery is the workshop. This is it, the ultimate proving ground. It's like this magical crucible where abstract ideas are put to the test and where raw chunks of metal, plastic, or wood are transformed by skilled hands into actual, functioning reality. So, welcome to this explainer on general workshop practice. We are going to bridge that gap between engineering theory and hands-on execution, focusing specifically on workshop tools, equipment, and their applications. Whether you're a student, an active tech, or an aspiring engineer, mastering this space is absolutely your golden ticket to building what you design. Here's a quick look at our agenda for today. We'll start with the engineering workshop foundation, move right into precision measuring and marking, and then tackle cutting, shaping, and holding. After that, we'll look at modern workshop power equipment and wrap the whole shebang up with smart selection and safety. Okay, let's jump right into Section 1, the engineering workshop foundation. Now, as an engineer, knowing how to pick and use the right tool is honestly just as vital as the design itself. Why? Because the right tools actually bridge the gap between theory and practice. They directly boost your productivity, they drastically reduce material wastage, and they're literally the only way you're going to achieve the required quality. You could have the most brilliant design in human history, but if you use the wrong tool to build it, you're just going to waste time and scrap perfectly good material. Moving smoothly on to Section 2, precision measuring and marking. Before we even think about grabbing a saw or firing up a machine, we have to follow a strict 4-step life cycle. Step 1, measure the raw material. Step 2, mark your reference lines. Step 3, secure the workpiece. And finally, Step 4, cut and shape the component. Skipping or rushing any of these foundational steps is a surefire recipe for creating scrap metal instead of a working part. Check out the huge leap in capability when you go from basic tools to precision instruments. Basic tapes and steel rules are great for your rough, general dimensions, but when your design demands serious precision, you absolutely have to step up to things like a Vernier caliper or a micrometer. We're talking measuring down to microscopic fractions of a millimeter here, which is a total game changer when parts need to fit together flawlessly. Once we've got those hyper-accurate measurements, we have to transfer them to the material using our marking tools. Think of scribers as basically metal pencils that scratch a fine, permanent line. Punches make these tiny little divots so your drill bits don't wander off target. Squares guarantee your lines are perfectly perpendicular, and surface gauges lock in those accurate parallel lines. And here's why this matters so much. A small error during marking leads to a major error in the finished component. It really is that simple. If your tri-square is off by even a tiny fraction of a degree right now, by the time you're done cutting and shaping, your final component is going to fail. So measure twice, mark perfectly, and cut once. Let's hit Section 3, cutting, shaping, and holding. There is a golden rule in the shop, and it goes like this. You cannot cut what you cannot hold. Securing your workpiece in a bench vise, a clamp, or a dedicated fixture is step 1 for both accuracy and safety. I mean, if your metal is vibrating or slipping all over the place, you instantly lose all that beautiful accuracy we just spent so much time establishing. With the materials safely locked down, we bring out the cutting and striking tools. We're talking hacksaws for your bulk material removal, chisels for carving out those really stubborn sections, and sheet metal snips for cutting the thinner stuff. And of course, hammers and mallets, which are completely vital for shaping, fitting, and coaxing parts together. I love this point here. Files are particularly useful for removing small amounts of material and improving the surface finish. They really are the unsung heroes. A hacksaw might leave a really nasty, jagged edge, but a file? That's your go-to for dialing in that perfect surface finish by hand, slowly bringing the material right up to your perfectly scribed line. All right, moving on to Section 4, modern workshop power equipment. When we scale up to heavy machinery, every single tool has a very specific primary job. Drilling machines give you perfectly accurate vertical holes. Lathes spin your workpiece at crazy high speeds for turning, facing, and threading. Bench grinders are your best friend for sharpening your hand tools, and welding machines, they literally melt and fuse metal components together permanently. The big takeaway here is that while hand tools teach you the literal feel of how materials behave, power machines provide way greater speed, power, and precision than manual operations ever could. They take your baseline skills and absolutely supercharge them with electric motors and high torque capabilities. Finally, let's wrap things up with Section 5, Smart Selection and Safety. Whenever you tackle a new job, you have to rapidly assess 4 crucial factors: the material being worked on, the type of operation, the required accuracy, and the desired surface finish. Are you cutting soft aluminum or hardened steel? Do you need a rough cut or a perfect mirror finish? Nailing these 4 questions means you are truly thinking like an engineer. And listen to me on this one. Safety is not a suggestion. It is a non-negotiable procedure. Always inspect your tools before use, because a cracked handle is a disaster waiting to happen. Wear your proper PPE, stick to the correct operating procedures, and please clean, check, and store your stuff correctly when you're done so it's safe for the next person. To bring it all together, master the tools to turn engineering ideas into real-world components. Knowing exactly what to use, why to use it, and how to use it safely is the exact magic that brings those abstract theoretical drawings to life. So, I'll leave you with this final thought before you start your next big project. Are you ready to step up to the bench, respect the tools, and actually build your design? Once you master these fundamentals, there is honestly no limit to what you can create. Thanks for hanging out for this explainer, and I look forward to exploring more amazing concepts with you next time.